Hello students, welcome to online maths classroom. Today we are going to study about L'Hospital rule. This rule is applied to evaluate the limits of functions which are forming indeterminate form. Now this is a very short and smart trick to evaluate the limits of such forms which are in indeterminate forms. So let us see. So let us see how to apply our L'Hospital rule for evaluating limits in indeterminate form. So let us take first example. Limit x approaches to 0, sine 3x minus sine 2x by x. Now you can clearly see if I put x as 0 here, it will form sine 3 into 0, that is sine 0. And you know the value of sine 0 is 0. And the numerator also sine 2 into 0, that is sine 0, that is again 0. So if I directly put this x as 0, the numerator becomes 0. Also, if I put the limit x as 0 in the denominator also becomes 0. So clearly this becomes a 0 by 0 form, okay, which is also an indeterminate form. Okay, so what we need to do is, in such cases we can apply L'Hospital rule to evaluate this limit. L'Hospital rule. Now how L'Hospital rule is applied? It is very simple. We need to differentiate both the numerator and denominator, and then we will put the limit. Okay, so that means ddx of sine 3x minus sine 2x numerator separately and the derivative of denominator, that is x, separately. Now let us see what does it become. It becomes derivative of sine 3x is your 3 cos 3x. Derivative of sine 2x is 2 cos 2x. And the derivative of x is 1. Okay. Now I can apply the limit here directly. So it becomes 3 into cos 3 into 0, that is cos 0, minus 2 into again cos 0, and the denominator is 1. Okay. Now we all know that cos 0 is your 1. So it becomes as 3 minus 2 upon 1, and the answer for this problem is 1. So see how simple it is to apply L'Hospital's rule. Let us see our next question. Our next question is limit x approaches to 0, e raised to power x minus 1 upon x square plus x. Now again you can clearly see that if I'll put x as 0 directly here, it will become e raised to power 0. Okay, e raised to power 0, which is your 1 minus 1 upon this is 0 square plus 0. So this is 1 minus 1 and 0 plus 0. So this is your 0 by 0 form. And we can apply our L'Hospital rule to evaluate this limit. L'Hospital's rule. Now how to apply? Again, what I need to do is I'll take the derivative of our numerator, that is ex minus 1, separately, and the derivative of our denominator, that is x square plus x, separately. So it becomes limit x approaches to 0, derivative of ex is ex, and derivative of minus 1 is 0. And here derivative of x square is 2x and derivative of x is 1. Okay, so both the numerator and denominator are differentiated. Now I'll put the limit directly. I can put it. So it becomes e raised to power 0 upon 2 into 0 plus 1. So anything raised to power 0 is 1. upon 2 into 0 is 0, and this is 1 upon 1, and the answer is 1. Okay. One more example. Example number 3. Limit x approaches to infinity, x square plus 4 divided by 8 raised to power x. Now see, if I replace x by infinity, it will be infinity square plus 4 upon 8 raised to power infinity. You know, 4 added to an infinite term is infinity, and 8 multiplied infinite times will give you infinity. So it is infinity by infinity form, which is another indeterminate form. So what we can do is we can apply L'Hospital rule, using L'Hospital rule. Now what we need to do is we will take the derivative of ddx of the numerator, that is x square plus 4, and ddx of denominator, that is 8 raised to power x. So it is limit x approaches to infinity, x square derivative is 2x, derivative of 4 is 0. Now what is the derivative of e raised to power x? It is e raised to power x log to the base e of a. Okay, so it becomes your 8 raised to power x log to the base 8. Okay, now see, can I apply the limit now? No. Why? Because if I apply the limit right now, it will again be in that same form, your infinity by infinity form. So what I need to do, I will again take the derivative of my numerator and denominator. So what is there? I will take the derivative of this 2x. So it is ddx of 2x upon ddx of your 8 raised to power x log 8. Now what is the derivative of 2x? It is 2, and the derivative of 8 raised to power x, we know it is 8 raised to power x log 8. So one more log 8 is there, so it becomes 8 raised to power x log 8 whole square. Now can I apply the limit? Yes. Why? Because the numerator is not infinity now, only the denominator is there. So what happens? The numerator will be as it is, and when I'll put infinity, it is 8 raised to power infinity log 8 whole square. So no doubt the denominator is reducing to infinity, but something divided by infinity reduces to 0. So 0 is the required answer of this question. Now let us take the last example for today. Limit x approaches to infinity, x square minus 9x plus 4, 3x square plus 7x plus 8. Now again you can see that if I'll put the limit as infinity, what is going to happen? Infinity square minus 9 into infinity, that is infinity plus 4, is again infinite, same as the denominator, and it is an infinity by infinity form. So again, by using L'Hospital rule, what I need to do is I will take the derivative of my numerator, x square minus 9x plus 4, and the denominator, your 3x square plus 7x plus 8. So it changes to limit x approaches to infinity. This is the derivative is 2x minus 9, and here is it is 6x plus 7. Now see, can I put the limit? No. Why? Because infinity minus 9, infinity plus 7 is again infinity. Okay, so again it is giving me an infinity by infinity form. Okay, so again I can apply L'Hospital rule. So I need to take the derivative of numerator divided by the derivative of my denominator 6x plus 7. Okay, so it is limit x approaches to infinity. This becomes your 2, derivative of 9 is 0, and this is your 6, okay, which is free from any x. So I think the directly answer will be 2 by 6, which is 1 by 3. So this is a simple way and a shortcut way of evaluating the limits of indeterminate forms. I hope the concept of L-Hospital rule is clear to you all. Thank you.